If you're asked to find the amplitude and the phase shift, we should first define what those two terms mean. We say that y equals cosine of x has an amplitude of 1 because it goes up one space and down one space from that blue midline that I have. Goes down to -1, goes up to +1. So the amplitude we just would say is 1. And so for the phase shift of a graph, that's if the y equals cosine of x starts here. A phase shift would be if you were able to manipulate the graph so it starts plus 4 spaces over here, minus 3 spaces over here. So let's look at the graph that we have. And if you practiced transformations before, you should know that adding a number to the domain variable before you do anything, in other words, inside some parentheses, that gives you a horizontal shift of pi/4 units backwards. It's kind of inverse of what we think. Adding pi/4 shifts the graph 4 units, pi/4 units backwards from where it starts. Oh, sorry, before we sketch the graph too, the amplitude for this one is also 1. Amplitude is affected by the number. That's the coefficient of the whole cosine and sine thing. If that had a 5, the amplitude of this function would be 5. But since it just doesn't have a number written, we say that the amplitude is 1, which means it goes starts at 1, it goes all the way down to -1, then back up. So now that we got that, let's do our pi/4 units to the left rotation. I guess I should say transformation. This is -pi/4, over 4. So the peak starts here, goes down to -1, then up to +1 again, and then repeats. So that's a rough sketch of our graph. It has that amplitude of 1 that we talked about. It has a phase shift of -pi/4, and then that's the rest of the graph. It just keeps going in that sinusoidal wave.